This is our last video in applying the exponent rules. It's very exciting. So we're going to talk about what happens when our bases also have coefficients. Because of course it's never going to be so straightforward and so easy as to just be just variables, right? Let's take a look at what happens when we also have coefficients. I thought the easiest thing to do here would just be to go through all of the 6 previous rules that we talked about and see what happens, what changes when we also have coefficients there. So when a base has a coefficient, oh my, we're going to apply the rules to the coefficients as well, but between coefficients, normal rules apply. So if we're multiplying, then we're multiplying those coefficients. If we're dividing those coefficients. If those coefficients are in parentheses, then we're going to apply those rules. Let's see what we mean. Okay, now this is our product rule. If we have bases, the same base raised to a power, we can add the exponents, right? We're going to add the exponents. So we have x to the 2 plus 3. But what are we doing with the big numbers here? Well, these numbers are multiplied together. There's a multiplication sign in between them. So we are going to multiply them. 3 times 4. Sometimes we like to say we're going to, when we're multiplying, we're going to multiply the bigs and add the smalls. Meaning, we're going to multiply the coefficients, but we're going to add the exponents. It's all multiplication. But this is the rule that we learned that we can apply. So 3 times 4 is equal to 12, and 2 plus 3 is equal to 5. Let's double check this one in Desmos. We had 3, and I'm even going to show you using the correct operations down here so that you can see exactly what I put in. We had 3 to the x squared, 3x squared, excuse me, 3x squared times 4, and we have to use something other than x, 4x cubed. And we're going to use m. And we found the equivalent to be 12m to the 5th. When we add the slider, these two things should be equivalent. We have to set this up something other than 1. Let's try, how about 7 today? These should match, and they do. So you are multiplying the bigs, the coefficients, and if the bases are like, you are adding the exponents. Let's try another one and see if... Here we have division. And it's very similar to what we just did, but instead of multiplying the bigs, we're going to divide the bigs. And since this is a quotient, we're going to subtract the smalls. We have 12 over 2 to the x, 12 over 2 times x to the 5th minus 2. 12 divided by 2 is 6. 5 minus 2 is 3. We've divided the bigs, subtracted the smalls for a quotient. And this is equivalent to this. And we can double check that in Desmos using sliders. If you want, you can pause the video and give it a try yourself. That would be awesome. What about this one? This is our negative exponent rule. And remember that a negative exponent is on the wrong side of the fraction bar. So this one needs to move up. What else is up there? Well, we still have this 5 up there. We still have this y up there. And we're going to move the x cubed up there and change the sign to positive. And another way that you can write this is 5x cubed y. And this is equivalent to this. Pause the video if you like. Maybe check that one in Desmos using sliders. We have a 0 power here. And we also have we have a coefficient raised to a 0 power. Well, if you remember back to the 0 power, everything to the 0 power is 1. I can distribute this in, or I can just say this base raised to a 0 power is equal to 1. And the answer here is 1. This is a power to a power. And we're going to raise everything in here to the 3rd power, including that 4. We have 4 cubed. We have x to the 1 times 3 because we multiply the exponents when we're raising a power to a power. And y to the 2 times 3. 4 cubed is 64. X cubed, y to the 6th. And I'm going to check this one on Desmos with you guys. I've used m and n in the place of x and y. This is what we started with. This was the equivalent expression. And when I add sliders and set them other to 1, you can see that they're equivalent. It's our last problem. And this one works just like the one above it. You're going to distribute this cubed into everything inside of here. You have 2 cubed. X to the 1 times 3 over 3 cubed y to the 1 times 3. 2 cubed is equal to 8. 1 times 3 is 3. 3 cubed is 27. And 1 times 3 is 3. And this is equivalent to this. And let's check this last one on Desmos using sliders. I've used m in place of x. I've used n in place of y. I've been consistent in doing that throughout. And you can see that these are equivalent to each other. I hope this was helpful. Thank you so much for watching. This has been Laws of Exponents. Email your teachers if you have any questions. We miss you a ton.